A composition of a function f with g is f of g of x, which means we plug g of x into f of x. Let's try some examples below. Part A wants us to find f of g of x. Now that is f of g of x. So f of g of x is our f function, 2x plus 5. But instead of plugging in x, I'm going to plug in g of x. So remember, g of x is 4x squared plus 1. So now I can simplify this composition by distributing 2 first. 8x squared plus 2 plus 5. So f of g of x is 8x squared plus 7. So we can also do the opposite. Part B. G of f of x is the same as g of f of x. G of f of x is going to have our g function, 4 times something squared plus 1, but instead of x, we're going to plug in f of x. G of f of x is 4 times 2x plus 5 squared plus 1. So now to simplify this and put it in standard form, I need to square that binomial. I'll get 4x squared plus 20x plus 25 plus 1. And then I have g of f of x is 16x squared plus 80x plus 100 plus 1. And I got that from distributing the 4. So g of f of x is 16x squared plus 80x plus 101 in standard form. Now that we've found this composition, part C wants us to find f of g of negative 1/2. So that means I'm plugging negative 1/2 into this function. So that's 8 times negative 1/2 squared plus 7. F of g of negative 1/2 is 8 times 1/4 plus 7. F of g of negative 1/2 is 2 plus 7. F of g of negative 1/2 equals 9. My input was negative 1/2. My output was 9. So we can add, subtract, multiply, find compositions of functions using the given notations, and evaluate them for given x values.